Hello everyone, welcome to Learn with Ease. On this video, we are going to learn how to run multiple linear regression using SPSS. So we'll learn how to interpret the results, the steps of running it, and how to interpret your results, what the values represent, how to um, know your predicted values and your residuals. Okay, so in my previous video, I introduced the linear regression. I explained the assumptions and what it's used for. Basically, it's used for prediction. So I showed us how to run the simple linear regression. So in this video, I will just run through the steps of how to run the multiple linear regression, and then I will interpret the results. So basically, the results are the same with that of the simple linear regression. The only difference is that we have more slopes. So instead of one slope, we have more. So this example we have here, now we are looking at both training hours and experience of the employees to see if we can use them to predict the monthly sales. Alright, so now as usual, click on Analyze, then we click on regression, then linear. Alright, so now we move in the dependent variable, which is monthly sales, to the dependent box. Then we'll move in training hours and experience into the independent box. So even if you have 3, 4, 5 or more independent variables, we'll just have to input them into this box. Alright, so we'll do every other settings that we did for the simple linear regression. We'll also do it here. So in case you've not watched the video, you can go back to watch the video, but I'll still show it here though. Alright, so click on statistics if you want to see if there's multicollinearity between the two independent variables. So select this, click continue, then we'll click on save, so that SPSS will generate the variables of our predicted values and the variables of our residuals. Alright, so now under predicted values, we select unstandardized. Under residuals, we select standardized. Then we'll click on continue. Alright, so now we have this. So that is all for the steps. Then we click on OK. Alright, so once we click on OK, we'll have our results. So this is our results. As you can see, if you've watched the previous video, you see that the table we have is the same. We have the same types of tables: the summary, model summary, the ANOVA, the coefficient table, and then we have the residuals tables. Alright, so now I explained what the R square is in the previous video and what the R and the R squared is. So the R typically tells you the strength and direction of the model. So it tells us that there is a strong positive relationship between the monthly sales and training hours and experience. Alright, so then we have the R square. So the R square now is telling us that that is the proportion of variance in the dependent variable explained by the independent variable. So here we have our R to be 0.876, meaning that 87.6% of the variation in monthly sales is explained by training hours and the experience of employees. Then we have the adjusted R square. So the adjusted R square is adjusted for the number of predictors in the model. So this is adjusted for the number of predictors in the model. So this is slightly lower than our R square to account for the inclusion of multiple predictors. Alright, so it means multiple predictors are included in this prediction. So that's it. Then the standard error of the estimate, which is the average distance that the observed values fall from the predicted values. So we have a smaller value which indicates a better fit. So our standard error here is 111.623. Then we move to our ANOVA table. So on ANOVA table, we have the our F statistics are significant value. So now on this regression row, the regression row represents the variation in productivity explained by the two predictors. So it explains the variation in monthly sales explained by the two predictors. Then the residual represents the unexplained variation in monthly sales. Right? So now we are looking at the F statistics. So the F statistics is the ratio of the explained variance to the unexplained variance. So here we have a high value indicating the model is significant. Also, we can also look at the significant value that tests if the overall regression model is significant. The significant value tests if the overall regression model is significant. So we have 0.000 here, meaning the model significantly predicts monthly sale. So that's basically what this tells us, that the model significantly predicts monthly sales. Alright, then we'll move on to the coefficient table. So under the coefficient table, like we said earlier in the last video, we have the constant, which is also the intercept, and we have the training hours, which is the slope. So we have the slope for training hours and the slope for experience. Alright, so now, like I said in the previous video, the intercept is the predicted monthly sale when all of our independent variables are 0. So yes, so this intercept, what we've gotten here, $2,868.006 or naira. This is currency. So 2,868.006 naira is the monthly sales that an employee will get even without an experience and without training hours. So this is saying that, okay, you as a manager, you employ someone to be a marketer for you, and even if you don't give that person the necessary training and that person doesn't even have the experience, what you should be expecting from this your employee monthly, or what on average is 2,868.006 naira on average. So that's what it's predicting there. That's what the intercept is predicting. That's what the value is telling you. Even if your employee doesn't have the experience and you don't give him or her the training, they will still make an average sales of 2,868.006 naira. So the slope of the training hours, is the increase in monthly sales for each additional hour of training, holding other variables constant. Yeah, so that's what this value here, the slope here, is showing. So meaning that for every extra hour of training, productivity or monthly sales increases by 106.038 naira. So this is what this slope here is indicating, that for every extra hour of training, monthly sales of that employee increases by 106.03 naira or dollars, as the case may be. Then the slope of the experience indicates that each additional year of experience increases monthly sales by 9.419 naira or dollar, as the case may be. Then then we look at the standardized coefficient beta for both slopes, the training hour and the experience. So if we look at these two values that we have here, we'll see that training hours is the strongest predictor of monthly sale. Why is it like that? It's like that because here we have 0.934, which is closer to 1, and when you have a number closer to 1, it indicates a strong positive linear relationship. While for experience we have 0.060, which is closer to 0, and if you have a value closer to 0, it indicates a weak positive linear relationship. So now comparing the two, training hours is the strongest predictor of monthly sale. So this invariably is telling us that it doesn't matter if the employee has an experience, or as long as he or she takes the training course, then they will make better sales. Alright, so now we move to the T statistics. So if we look at the T statistics, you see that the T statistics of training hours is higher than that of experience. So this actually is showing that the training hours has more significance on the monthly sales than experience does. Then the significant value, which tests the significance of each predictor. So we can see the significance of each predictor here. Then if you look at the value of significant value of training hours, you see that we have 0.000, and that of experience we have 0.564. So now this value is telling us that training hours contribute significantly to monthly sales. 0.005 is less than 0.05, so it indicates that training hours contribute significantly on predicting monthly sales. Then if we look at the experience, we see that we have 0.564. This is way higher than 0.05. So this means that experience has no significant effect on training hours on monthly sales, which is the dependent variable. So from here we can see that the experience does not contribute significantly to predicting monthly sales. So let's not forget that we have our significant value here. So this significant value here shows overall that the independent variables has a significant effect on the dependent variable. So this is in general, but this is where we see the individual differences, if there's individual significant effect or relationship between the dependent and the independent variable. So here we can see that the training hours significantly predict monthly sales. Significantly predicts monthly sales, while experience does not significantly predict monthly sales. So basically this is what the coefficient table is telling us. So now if we want to know if there's multicollinearity, that is if these independent variables, if both of them are similar or correlated, which one of the assumptions says they should not be similar, they should not be correlated. So this is where we know that from the collinearity statistics we have the tolerance and we have the VIF, which is variance inflation factor. So this variance inflation factor is one way we can check for multicollinearity, and tolerance is another way we can check for multicollinearity. So we can decide to use the both of them, or we can decide to use just one of them. So the range is that for tolerance 1, just like we have the value here 1, it indicates no multicollinearity. So it indicates that there's no multicollinearity. So if we have a value that is close to 1, it means there is no or low multicollinearity. That is, if we have a value close to 1. But if we have a value that is below 0.1, it means that there is high multicollinearity. So when there is high multicollinearity, we can't use our results. We can't run the linear regression. But if we have a value close to 1, it means there is no or little collinearity that we can use. If there is no or little collinearity, we can use it. If we have no collinearity at all, we can also use it. But if there is high collinearity, which means our tolerance is less than 0.01, it means there is high collinearity and we can't make use of the model. So this means that the two independent variables are similar. So in other words, what do? You can simply remove one of them since they are similar. Then for the VIF, variance inflation factor, here if you have a value 1, just like we have here, it means there is no multicollinearity. But if you have a value between 0.9 or so to 5, between let's say 1.1 to 5, it means there is a little or moderate collinearity. When there's little or moderate collinearity, you can go ahead with the analysis. But if it is above 10, if the value here is above 10, it means that there is high multicollinearity, and so you should either remove one of the independent variable, or you just don't do carry out the test. Yes, so that's basically how this indicates multicollinearity or not. So that's the range. All right, so that is it on this video. I hope you got what you're looking for, and this video is quite helpful. So please like, share, subscribe, and watch out for more tutorials.